What if I told you the universe just broke its own rules? Scientists have found a black hole, between 225 and 255 times the sun's mass, that no theory says should exist.
This isn't just a surprise, it's a cosmic shockwave.
If something this forbidden can form, what else is hiding in the universe's shadows? Could this monster mean our understanding of space is way off, and force scientists to rewrite the story of how cosmic giants are born? Imagine a black hole so heavy it tips the scales at more than 200 times our sun. That kind of cosmic heavyweight was never supposed to exist. Every astrophysics textbook draws a bright red line through that mass range, meaning, don't even look here. The models all said the biggest stars shouldn't leave anything behind. Their explosive deaths ought to rip them to shreds. And yet, here's the shocker. Astronomers have actually found one of these impossible giants, sitting smack in the middle of forbidden territory. For decades, scientists have talked about the upper mass gap. Think of it as a ghost zone in the black hole census. Too small, and a star becomes a white dwarf. A little bigger, and maybe you get a neutron star, or a small black hole. But stars between about 60 and 130 times the sun's mass? According to the rulebook, they shouldn't leave any trace behind. The explosion should be so violent that not even a black hole survives. That was the neat theory anyway. Scientists always expected to find a bunch of small black holes, and maybe a few supermassive ones, but absolutely none in the middle. So how on earth did we find a black hole this big? Where did it come from? What rules got broken here? That's where everything gets wild. This discovery doesn't just blur the line. It leaps so far past the forbidden zone that the old rulebook may as well get shredded. It's like if a zoologist told you a species went extinct ages ago, and then one just walked past your house on a Tuesday. That's the kind of jolt astrophysicists felt. If stuff like this blows your mind, tap subscribe so you're here for the next cosmic curveball. The universe clearly doesn't care about our neat boundaries. Every time scientists think they've mapped out safe regions, nature fills them with something even stranger. It's like the universe just tore out a page from our theory and scribbled its own secrets right in front of us. And here's why this matters. By all the old models, a star inside the mass gap should be doomed, gone completely, not leaving a single trace. A black hole over 200 solar masses was the stuff of total fantasy. Now it's real. Impossible yet undeniable. But this isn't just about one oddball discovery. It means the whole story of how massive stars die could be full of holes. What if there are entire hidden populations of impossible black holes out there, living quietly where nobody thought to look? And if these rules can break so easily, what other forbidden cosmic objects are out there, just waiting to write everything we thought we knew? This monster didn't show up in a photo. No telescope ever caught its shadow. Instead, it thundered across the universe as a ripple in space itself, a gravitational wave, shaking reality for less than a heartbeat. Imagine not seeing evidence, but feeling it roll right through our planet. That's how this impossible black hole made its entrance. Here's the setup. Detectors like LIGO and Virgo, each with long L-shaped tunnels and ultra-precise lasers, wait for space to tremble. When a gravitational wave passes, it stretches and squeezes those tunnels, knocking the laser beams out of sync. In that moment, the entire Earth becomes a cosmic sensor, letting us listen for cataclysms far beyond their reach of any camera. But this wasn't just another faint blip. The signal lasted 1/10 of a second, a sharp, powerful burst, like a deep bell ringing through the silence. Both LIGO detectors in the US caught it almost instantly. Random noise? A local glitch? No way. Only a true cosmic event could leave a fingerprint like this in 2 detectors at once. But one epic signal isn't enough. The real challenge is pulling secrets from that fleeting moment. Because this wave, it nearly slipped right past our instruments. Decoding this wave was no easy feat. The signal hugged the edge of what LIGO and Virgo could even detect, barely more than a whisper. Scientists had to squeeze every clue they could from a single fleeting blip. Imagine staring at a smudge on glass and somehow reconstructing a disaster that happened billions of years ago. But it's more than data. Picture a scientist, eyes locked on the monitor as the line surges. That's the echo of monsters colliding, long before Earth was even born. A ripple that traveled 10 billion light years, but moved our world just enough for LIGO to feel it. That's how we know the impossible really happened. Not through an image, but from the universe itself, ringing like a bell. And if a flash this brief almost broke our instruments, how many even bigger shocks are still out there, rattling the cosmos and just waiting to be heard? If stars can't make black holes this huge, where do these giants actually come from? That's the puzzle. Even the biggest stars we know shouldn't leave behind black holes this massive. The laws of stellar death say giant stars lose too much mass in their explosive ends. Nothing so heavy should survive the blast. And yet, here we are, staring at a cosmic rule breaker. One big idea is called the merger tree. Imagine a black hole family tree. Not parents and kids, but smaller black holes crashing together, over and over. Start with two ordinary black holes, maybe each a few tens of solar masses. In dense, crowded star clusters, they spiral together and merge. Now you've got a heavier black hole, primed to crash into the next one. Stack that process up, and over time you get monster black holes built from layer upon layer, like cosmic Lego blocks, eventually landing in the forbidden size zone. Dense star clusters are key. Picture them as cosmic mosh pits, everything packed tight, full of wild encounters. In these environments, black holes merge far more often than if they were drifting alone. What's rare in empty space becomes routine, and a few generations of mergers can produce true giants. But that's just one path. There's another, even wilder idea: skip stars completely. Start instead with a massive cloud of gas. Instead of forming dozens of little stars, this whole cloud collapses at once, directly into a giant black hole. No explosion, no leftover mess, just an instant monster. These black holes are born big, never ordinary stars at all. And it gets crazier. The James Webb Telescope has spotted surprisingly chunky black hole candidates from the very early universe, way bigger and earlier than anyone expected. If those are real, direct collapse could be the universe's go-to move for making monsters. Every path rewrites the story of how cosmic structures come together. If black holes can pile up from mergers or appear full-size from the start, our whole picture of how galaxies, and their mysterious centers, form is up for grabs. And if rule-breaking giants like these exist, just how weird could the black holes hiding in our own Milky Way truly be? The universe ignores our boundaries. This black hole, hundreds of times heavier than the sun, was supposed to be impossible. Yet here it is, tearing up the rulebook and reminding us just how much we have left to discover. Gravitational waves are catching black holes that break every expectation, revealing a cosmos far stranger than any textbook. If monsters this forbidden can exist, what else is out there waiting to be found? What if this is only the beginning? Want to be first to know what the universe reveals next? Subscribe to Infinite Echo, because in space, the only rule is, expect the impossible.